Hi everyone. So welcome to again this session. I'm going to solve again one question from semiconductor physics. This time I have taken a question from GATE 2015. Okay, and this question is again from electronic devices. So certainly you have to use the very important tool that is called as energy band diagram. Okay. So let us see how much time we are going to consume to solve this kind of questions. Okay, and I'm pretty sure that you can solve this question in 3 seconds, just 3 seconds, or you can say maximum 10 seconds. It will not take more than 10 seconds. Okay, let us see this question. So the question here is question number 35. As you can go through the question, the energy band diagram, and so this time they have already mentioned that the energy band diagram is given. Okay, so already they have specified the energy band diagram here. Okay, this is the energy band diagram. Please have a look. Okay, your observation matters a lot. Okay, if you look at the energy band diagram, okay, so you have to feel like a device engineer, right? So this energy band diagram is given, and the electron density profile is also given. That is also great thing. Okay, they have mentioned here the profile is also given in a semiconductor are shown in the figure. Okay, assume that some expression they have mentioned. Okay, like how your electron concentration varies with respect to position, right, as you move in the semiconductor. So how your doping has been done, so you can understand here the doping is not uniform again. Okay, doping is not uniform. Okay, at one end of the bar you can say the doping is more, at one end of the bar doping is less, right? So certainly there will be diffusion current. Okay, but they have given here n of x. Okay, and x expressed in centimeter, right? And these values are given like kTyq, some diffusion coefficient is given. In fact, Einstein relation is also given, that is d by mu equal to kTyq. Okay, now they are asking what is electron current density in ampere per centimeter square at x equal to 0. So what they are asking is they want us to compute electron current. Okay, electron current density they are asking, electron current density. Okay, so they did not mention about whether they are asking the drift current or a diffusion current. Okay, in fact they did not talk about any sort about equilibrium also. So what I will assume here is that the given energy band diagram and given semiconductor material is in equilibrium. Okay, since they haven't specified any sort of external voltage and anything, okay, you can go through this, nothing is applied. Okay, simple one semiconductor is given like this is a semiconductor, and this has been non-uniformly doped. Okay, the doping has been done gradually. Okay, the doping concentration has got increase or decrease, you can say, gradually, right? Okay, I hope this makes sense. And this is log of nx, not the, okay, so these things does not matter, please remember. Okay, they are asking you to find total electron current density. Total electron current density means what? The diffusion current plus the drift current. So what do you think? As far as the semiconductor is concerned, semiconductor is in equilibrium. Okay, and if you look at the energy band diagram, there is a slope also. Okay, there is a slope. Let me show here. There is a slope. Okay, if you look at this, so you can take one Costco ball here, right? So your drift current will be in this direction, you can say. Okay, the drift current, you can say J drift, is going to be in this direction. Okay, now the question is in which direction the diffusion current is going to be. So certainly your diffusion current will be in this direction. Okay, this is J diffusion. Okay, and what they are asking is they are asking you to find electron current density, and one more thing they did not specify here is the Fermi level. Okay, they did not talk about Fermi level. Okay, so as far as the inner, semiconductor is concerned, it is in equilibrium. So your Fermi level is going to be constant always. Let me mention that also. Your Fermi level will be constant. Okay, you can say that your Fermi level will be constant. Okay, okay, your Fermi level will be constant, right? So spacing is not given properly. Let me draw that properly, okay? Otherwise this diagram will be wrong, okay? So let me take the energy band diagram here, okay? So your Fermi level is here, and they have given this kind of energy band diagram, right? So Fermi level is constant throughout. It means there should not be any current. Qualitatively, that we know, but they have given some electron concentration. You know how electron concentration really varies, okay, exponentially with respect to position. Okay, so our conclusion is what? If the semiconductor is in equilibrium and the Fermi level is constant, the net current must be zero. The total current should be zero here. The diffusion will be cancelled by the drift. And why I'm saying that diffusion will be cancelled by the drift? Because there will be electric field. Because if you look at given energy band diagram, okay, there is a slope. So slope in the bands, bending in a band tells you there is a electric field, okay? And if there is a electric field, right? So because of that electric field, electron will be drifting downward, okay? Electron is going to drift downward. So electron drift current will be, you can say, from in the negative x direction, right? And your diffusion current is going to be in the positive x direction, okay? So they will balance each other. So what is the option that is going to be correct according to our qualitative understanding of devices, qualitative understanding of energy band diagram? So the answer for this question is going to be option C. Many people, what they do is they will waste your time. Let me tell you clearly, okay? They will waste your time, guys. In fact, if you look at the publisher books also, right, different publications, you guys are breaking your head, okay? So what is my suggestion is going to be here, being as kind of senior educator, for different branch of engineering. I will suggest that if it is a gate question, right, it is not going to take more than 120 second or 180 second. मोर देन 3 मिनट कोई भी क्वेश्चन नहीं लेने वाला है. ये क्वेश्चन तो आपका 10 सेकंड का है, ठीक है? तो कैसे हम 10 सेकंड में आंसर कर रहे हैं? जीरो आंसर कैसे आ रहा है? देखो, पहली बात तो आपको पता होना चाहिए कि सेमीकंडक्टर है. सेमीकंडक्टर के करस्पॉन्डिंग एनर्जी बैंड डायग्राम इज गिवन and there is a slope in the band. They did not specify about Fermi level, but आपको समझना है कि अब कोई भी एक्सटर्नल वोल्टेज अप्लाइड नहीं है तो अपना सेमीकंडक्टर इज इन इक्विलिब्रियम ओनली, ठीक है? इट मींस नो करंट शुड बी इन द मटेरियल, नो करंट शुड बी इन द डिवाइसेस, ओके? जब आप कुछ अप्लाई नहीं कर रहे हो तो करंट किस बात का? लेट्स से यू हैव अ डिवाइसेस, ओके, एंड यू डिड नॉट प्लग इट टू एनी एक्सटर्नल वोल्टेज, सो व्हाई दैट डिवाइस विल रन? डिवाइस रन करेगा तो आपका तो पावर ही वेस्ट होने वाला है ना. आई होप दिस मेक्स सेंस, राइट? सो दिस क्वेश्चन वाज, आई डोंट नो हाउ दिस क्वेश्चन इज डिफिकल्ट, राइट? बट हाँ, अगर आप फ्रेशर हैं, इफ यू आर right now you are studying devices, let's say you never faced electronic devices, you haven't got a good educator who can teach you electronic devices in this manner using energy band diagram. Because in India I have seen in gate, particularly in gate community, in gate industries, right, in education industry, who teaches for gate, nobody teaches electronic devices using energy band diagram. Sometimes they will say, okay, this energy band diagram was asked in this paper, so you guys can have a look. But in India, many students, you can say 95% student do not know how to draw the energy band diagram of any semiconductor device. 95% हम बता रहे हैं, 5% को पता है ना? टायर 2 टायर 3 वालों को तो पता ही नहीं है, ठीक है? मतलब आईआईटी और एनआईटी में जो पढ़ते हैं उनको पता हो सकता है, और कुछ और भी स्टूडेंट्स हैं उनको पता रहता है. बट व्हाट आई एम ट्राइंग टू कन्वे हियर इज द, इनफैक्ट बहुत सारे जो कॉलेज में टीच भी करते हैं इलेक्ट्रॉनिक्स डिवाइसेस, सेमीकंडक्टर, दे क्लेम दैट दे आर वेरी गुड इन इलेक्ट्रॉनिक्स, ऑल दीज थिंग्स, राइट? उनके क्लास में अगर आप जाओगे ना तो वो फिर से वही इलेक्ट्रॉन होल ऐसा वैसा करके बच्चों को फिनिश. सो understanding the devices is very important. In my case, across India, I have visited all the colleges. You talk about any college, in private or government, right? I have visited almost all the district in India, right? All these states, ठीक है? तो मैंने वहाँ पर देखा, in fact, I have met various professors also जो वहाँ काम करते हैं. तो उनके केस में भी दे आर नॉट एबल टू डिलीवर दीज थिंग्स, उनकी गलती नहीं है, सिंस दे आर टेकिंग दैट एज अ जॉब ओनली, राइट। देखो टीचिंग एक जॉब है, अपना फैमिली चलाना है, ठीक है, लेकिन टीचिंग का मतलब ये नहीं होना चाहिए कि बस हमारा खर्चा पर्चा चल रहा है और हम पढ़ाए जा रहे हैं कुछ भी। बच्चों को फायदा होना चाहिए, मजा आना चाहिए, तो आप खुद इंजॉय करो एज अ टीचर, अगर आप टीच करते हो डिवाइसेस तो। Before you claim something, see, I'm claiming here that I teach electronic devices using energy band diagram. So yes, it is true. Many student knows that. ठीक है, आप आंसर देख सकते हो इसका। अब इस क्वेश्चन का कोई भी सोल्यूशन नहीं है, इसका डायरेक्टली आप आंसर बोलोगे जीरो। अगर आप कैलकुलेट भी करोगे तो आंसर जीरो आने वाला है। So it is one of the great question, right? I hope you might have enjoyed. Thank you. We'll meet in the next session.